Feel free to grab your chocolate because you're gonna need it for the lunch. You can, yeah, go for it. As many as you think you want.
Like half and half or just two?
I would just choose one and then you could grab some for the second part. Yeah. Remember, you're gonna be counting all those. That looks like it might be a lot. You get what I'm saying? So as long as you're okay with counting that many, I'm not trying to limit how much chocolate you eat. Just that looks like a lot to count. You get what I'm saying? Okay. And maybe grab like some I'll grab some paper towels for everybody so you can like kind of lay them out. Make sure you at least have like 10. Okay.
Is that the minimum 10?
No, there's no limit.
Oh, okay.
Like you could have
As much as you wanna count.
yeah, as much as you want to count. Like
You don't
somebody
want
did
to
the
count.
lab. I graded somebody's lab this morning and they did 602. They counted 602.
Okay.
And I told them, I was like, oh my God. Oh, and make sure you get some more chocolate, okay? Oh, down. So it doesn't get all over the table. There you go. To help you count. You don't have to put it on the desk. Oh, just grab a cup. Okay. And then just get as many chocolate as you want to count. Okay, as many as you feel like you want to count. Okay. Ashley,
Hi.
glad you're here
Thank you.
and you're on time, making me happy. So I just want you to grab the cup. And grab as much chocolate as you feel like counting. So you will have to count as many as you grab. Just keep that in mind, okay? So don't grab like a full cup, because that would be crazy, okay? Are you sharing, Misty? Or did you grab too many? Now you know you have to count them, right? No, somebody did their lab earlier and they got 602 chocolates that they bought. And I was like, you're crazy. So while we're waiting for some more folks, if you want to just go to the modules that open this lab too, that's what we're gonna do today. And yes, you get to eat the chocolate when we're done, but we're gonna do 2 experiments with it. So and I'll walk you through as much as you want, but if you want to just download it and maybe set up your chocolate however you want to count it, just make sure you don't have too many, okay? So yeah, so this is the way your labs should look. It says 1.69 ounces or higher. I would say just at least 10. If you have less than 10, it's going to be really hard. So make sure you at least have 10 pieces of chocolate. If you've got 50, that's cool. Grab as many as you want, but you know you're going to be counting 50, okay? If you can't access the lab, let me know. But we'll wait a couple more minutes. Hopefully we'll have some more folks in here. Otherwise, I will eat the rest of the chocolate, and I do not mind. Yeah, but I thought she was a little crazy for 600. And she was like, no, I put on gloves. And then when I was done, I got to eat them all. It was great. The lab has 5 parts. It's a 5-part lab. There's experimental and theoretical probabilities. There's paragraphs you have to write. So I'm just going to remind you for your paragraphs, what do you need? No contractions. Let's write proper English. Like simple prose sentences. No more run-ons. That'd be great. Good evening. Just know you will have to count them. Okay. I don't know if that stops you, but you can get more. No, you'll be counting it. Going, doing great, grab a cup, and just grab as many chocolates as you
No, I
can.
like what you're saying.
Okay. Remember, you don't have to count those. So, you got it?
Yes.
Awesome. Or you could save some to eat and then count the ones you're going to use, but that might get confusing, right? So everybody just open your lab 2. It's in the modules. I'll wait like another minute or so. Hopefully we'll have some more folks here. Hoping REA and Sam will join us, but if not, that's okay. Natalie's here, Leah's here, okay. But yeah, this is in your modules. I'll show you where it is. If you go to modules, it's lab 2. And I don't know if you saw the email I sent. I got less homework when I did other stuff that wasn't the homework. So I'm just going to do the homeworks in here. or whatever is going to be graded, because I don't want you to fall behind. I was trying to teach you probability, but I'm just going to do the homeworks for your probability. I hope that helps. So I just want your life to be easier, but I also want to make sure you learn this stuff. So where's lab 2? It's right here in probability. Okay. Hi, Sam. Hi, Kelly. Glad you're here. Hopefully REA comes to join us. Grab yourself a cup. And as many chocolates up there that you feel like counting, okay? You got it? Here you go, Sam. And grab yourself some chocolate, okay? So how would I do this lab if I were you? The first thing I would do would be separate my chocolate into colors. I gave you one of these, so you can sprawl it out and make it not touch the desk if you're a germaphobe. If you're not, count it how you like. So just make sure you don't get too much, otherwise counting will be a pain. Somebody did, you. One of my students did 600 and I thought she was crazy. All right, so it doesn't matter what you want to grab. The first thing I would do is separate them into colors, okay? So here's your first lab. This is what your lab should look like. I clicked enable editing, so I'm going to draw it just like you did. And why don't we do this like so it's nice and fun? Could I get a volunteer to read under M&M probability? That'd be awesome. Thank you. I appreciate it.
Or just like you get when your results in the doing, you open the bag of peanut almond peanut butter and casey or medium. Whenever you start to use the word most likely or least likely, you are talking about probability.
All right, so I want everybody to make a couple of guesses, okay? Think about which is most likely and least likely before you start divvying up. Otherwise, that's okay. So just go and grab yourself some chocolate. Just know all the chocolate you get, you're gonna have to count. And Alejandro, you need more chocolate. You have like 8 pieces. I need a little bit more than that. I'm sorry, you're gonna have to eat some more chocolate. So let's make some guesses. Does anybody think a color is gonna happen to be most? Anybody have any guesses for this? You like orange? You know, that's funny. The other student got orange as their most, so we're thinking orange is most likely. What about a color for least likely? Anybody have a guess? A hypothesis? We're going brown is least likely. All right. Alejandro, you got a couple more?
Yeah.
I appreciate that. I just want your math to be slightly more challenging. All right, so the first step in this, I made sure I didn't get like peanut or anything because I didn't know if people had allergies or whatever. So I just got like the regular and the small ones. Why do I have 2 different kinds? Because whatever size you didn't use, I want you to do for the second part of the experiment. Well, it's actually the 5th part of the experiment. I know it sounds like a ton of parts, but it's really easy. So the first thing is take a bag, whatever. Remember, the larger bag size, the larger sample you have. So the more M&Ms you have, the closer to the actual sample size you'll get, which is kind of cool. And the first thing you have to do is get your N, your total. Okay? Now, whatever your total is, we're just going to count that first. So count how many you have. I think it's easier if you separate them, because when you separate them, it'll make all your calculations easier. Okay? Has anybody counted them already? Natalie, have you counted your M&Ms? How many did you get? You got 26. That's what I'm using. I like it. It's an even number. If you don't have 26, that's okay. This is my example. Okay. And then you count how many M&Ms are in each pile. And then we have to answer these very simple questions. Largest, smallest, and was it expected what you were to find? So I'm gonna ask Natalie for your help since you're gonna be my exam. Is that okay? All right, so how many, what color did you do first? You got 5 blue, okay, and keep going. We got 8 oranges. I thought the plural of orange was orange, unless I'm crazy.
Oh, sorry.
No, you're fine. We got 4 brown, keep it up. We got 3 yellow, 3 green, and 3 red. Cool. Our mode would be 3, just so we know. So for Natalie's, her most was orange. Tenzin, you had orange too, right?
Yeah.
That's so crazy because the 2 that I graded this morning also had orange. Does everybody have orange as their most, or is it just some luck of the draw? You don't? Oh, crazy. All right, and now do you see how Natalie has a tie for her least? So her least is going to be 3. Your least is going to be yellow, green, and red. All right. Is it what we expected? I don't really know what we guessed. We guessed orange was the most. We were right. We guessed brown was the least. We weren't right. So all you have to say, is it what you expected to find? Give me a sentence. I don't care what you write as a sentence, as long as it's in a what? Full sentence with a period. I'll be happy. Yes, this seems typical. Most were equal values. How do you like that? Well, it's not most. Half were equal values. Isn't that cool, right? What would we expect? We'd probably expect them all to be 5, right? 5, 5, 5, 5, 5, 5. But we got some that were big, some that they were even. So just write whatever your data was, right? Whatever data you came up with, just give me a sentence, right? I thought it was pretty typical. However, I thought I'd get most to probably be 4 or 5. You probably think they should be even, right? Does anybody have a perfect breakdown? Is anybody's even across the board?
Except for one.
That's pretty cool. I'm glad you got a couple more. All right, so don't eat them yet. Okay? You can eat all of the ones you have soon, I promise. Any questions so far? Anybody lost? Nobody's lost? Okay, so guess what? Now we have to do calculations. So we're going to calculate the probability of picking a certain color M&M for each category. The probability is found by creating a ratio. So it's just what you want over the total. And then we have to make it a percentage by doing what? Timesing that decimal by 100. So I'm going to keep using Natalie's. I'm going to put your total at the bottom. It was 26, right? The first thing I'm doing is I'm just going to write the colors. Blue, orange, brown. All right. And you just can type yours in. I'm going to write it orange, brown, and we got yellow, green, red. Nobody's lost, right? We're probability pros. All right. Now, those are the colors. Now, what about frequency? What does that mean? Frequency is just the amount they happen. It's just the amount that shows up. So all we have to do, well, didn't we already count them? Just write in the numbers. So it's minus 584,333. And please let me know if I'm going too fast. We add all these up. What should I get? 26, 3, 6, 9, 13, 21, 26. We did it right. Cool. Yes.
Can we have 2 of the largest quantities? Like 2 even ones?
Oh yeah, of course. I had 2 of the smallest ones. You could have 3 of the largest quantities. You know, in a perfect world, guess what? They'd all be equal. You'd get the same color, the same amount of times. You could have 2 largest, 2 smallest. That's a great question. So we had 1 largest in this case and 3 smallest, but that's fine. Anybody else? Other questions? Nobody's lost? Please let me know if I'm going too fast. Now the ratio. Remember, for full credit, we have to write what the step. Okay? You can't just write the answer. So it's just what we want over the total. So I want what? 5 over 26. Can I simplify that? That's where I'm staying. Make sure your fractions are simplified. Now I have 8 over 26. I could divide it by 2. So I have 4 over 13. Flying along. Now I have 4 over 26. What is that? 2 over 13? Yes. Now I got 3 over 26. Now, how do I know 3 doesn't go in? Remember your numeracy rules, okay, everybody? Really try to remember those numeracy rules. What is 2 plus 6? 8. Does 3 go into 8? No. So 3 doesn't go into 26. If you ever want the numeracy rules, I can write them all out for you. There's a rule to know if a number goes into another number. But if it adds to a multiple of 3, like if this was 27, 2 plus 7 is 9, then 3 goes in. Does that make sense? All right, sorry. My last 3 are the same. They're all 3 over 26. And we're good. Now, notice on the bottom, this is what people messed up already. You didn't grab any?
No, I do.
Okay, one more. Grab as many as you want. I will not stifle anybody's hunger. So if you need more as you're working through this, go eat more. Just don't eat the ones you have yet. I know it's tempting. So we have to get our total. You see how there's a line right here? Some people forgot this. And when I was grading a lot of homework, some people forgot their total line on their frequency table. Don't forget the totals. It's important. So this is going to be what? 26 over 26 right here. Which simplifies to what? 1. Make sense? All right. Please ask me questions, slow me down. I know it can go fast sometimes, but now we have to do the percent of the total. So we need a percentage. All we have to do is remember we got a little percent here. So to get the percent, I'm just going to be multiplying whatever decimal I get by 100. So my first one is 5 divided by 26, and I'm going to ask Natalie because they're your numbers. What's 5 divided by 26? So you got 0.192, right? So it's 19.2%. Beautiful. You want to give me the rest of yours?
30.7.
Oh, so point.
Got 0.3307.
For 8, yes, 0.307, which is times 100. Notice that I'm writing the steps here. Yes, question.
So you divide this up by the bottom number?
That's all a fraction means. And then you times it by 100 to make a percentage. All right. I only need 2 more from you.
153.
Oh, I already made a mistake. Give me a second. I thought it was going to be 14%. It was 13%. So it's 153.
Yeah.
I was so close. I was trying to do it in my head. All right, so 15.3. All right, the next one is the last one I need.
115.
0.115 times 100 is what? Notice that I have my steps here. Notice that I put, it's the decimal times 100 to get the percentage. That's what I want to see, okay? Don't just write the answer for your homeworks or for your stuff. Like, show me the steps so I can give you full credit. Now, why did I tell Natalie she could stop? The rest are the same, right? So this is 11.5%, 11.5%. If we add them all up, what should my percent be? We got it, 100%. So the bottoms of everybody should read what? 1 and 100. Sound good?
I have a question.
I love questions.
Okay, I happen to get 100 M&Ms, so.
You got 100 M&Ms? That's so cool.
So,
No, I will survive. That is really cool. Did you just happen to guess 100 or did you have 103 and eat 3?
no, about 100,
That's so cool.
yeah.
That's really going to help you in part 2 because one's like, what would it be out of 100? You already know. All right. Does anybody need more time on this part? Yes, I will pause. So let's at least read number 3. Remember, the more likely something is closer to 1, the the probability will be, that's such a bad question. Good thing I didn't write this. And so now we answer the following questions. I'd fix it, but you already downloaded it. So, which one is most likely? In our case, it was orange. Orange is most likely. We're flying through this, right? Super easy. I love the questions. Keep them coming. That was your rounding. That was just rounding. So you can round it up to 100% for the bottom. Because when you added all these, right? You got 99.9. That makes sense because you're rounding. Other questions. I love the questions. All I can do is smell chocolate, so I'm doing great. Alejandro, you good?
Yeah.
Why do you look so confused? What did I do wrong?
No.
Okay. Is the probability making more sense? All right, cool. All right, let's keep going. Ashley, you feeling good? Yes. All right, let's move on. Least likely for my case was, oh, 3 of them. So I got to write yellow, green, red. And look at the next one. It's the same. Do you have any that are equally likely? We have yellow, green, and red. Yes. And Alejandro, you're going to have like 5 of them, right? Because all of yours are the same except for one?
Yeah.
Cool.
How many people's M&M's the least amount is green?
My least is green. Who else has the least of green? 1, 2, 3, 4, 5? Interesting. Yeah, greens are usually the least. I've seen that a lot. I think it's because there was like people think the green M&Ms have some like connotation that's inappropriate, so they've been putting less in, but I highly doubt that. It was the most. Okay, good. Good. That makes me feel better about it. So you all evened out. So Sam has your greens. That's what happened, REA.
That's a small bit of green.
Okay. All right. Any questions so far? All right. Now we have to do our prediction. So this is what people messed up. I was emailing one of my students back and forth. He couldn't figure this out, but guess what? We're all in this together. So we have to make a prediction. Now I have only 26. How can I predict for 50? Do you see how we already have our relative? See how this is 19.2%? You could do this a couple ways. One way you can just cross multiply. If you love the butterfly method, do the butterfly. What do I mean by that? All right, so I have 5 out of 26, right? I want to know how much it would be out of 50. You see that? And I just cross multiply. Boom. 26 times x equals 5 times 50. That's 250 divided by 26. I'm going to show you an easier way in a second, but this is how you do it. You make a little proportion. 250 divided by 26. I'm just going to pull up a calculator because it's being recorded, so everybody can see my math moves. 250 divided by 26. 9.6. Now we're making a prediction. Can I have a half an M&M? No. Because it's 9.6, I'm rounding up to make this how many M&Ms? 10. Now, what is the faster way? I'm always going to show you the faster way. We already have its percent of the total. 19.2 or 0.192. What happens if I multiply this by 50? You can always take the relative and multiply it by the amount you're looking for. So you know how we have 0.196? If I multiply that by 50, I lost the calculator, just trying to bring it back up. 0.196 times 50. We should get, better be 10. 10. See how fast that was? So you can take your relative, if you don't like this, if you don't like making a proportion and cross multiply, this is the way I always do it, because I like seeing where my numbers come from. But if you don't want to make a proportion, you can take your relatives and times it by what? The total. You do your relative times the total, you'll always get the amount you're looking for. I'll do another one. So the first one was. We did, what color was our first one? We did a blue at 50. Wait, I don't have blue. Well, I'm writing blue in. I got a blue at 50 and it was 10. Was that okay? We're just predicting. So let's try the brown. The brown was what percent? Brown was 15.3. I can just do 15.3 times 50. Sorry, 0.153. Make sure it's the decimal times 50, and you're going to get that amount. So we have 7.65 round up because it's 5 or more. So we're gonna predict that if I had a bag of 50, I'd have how many brown? 8 brown. Is this making sense? Not even close. It's okay. I'm gonna show it a different way. All right. So Sam, tell me how many orange ones you got.
9.
9. And what was your total? 53, okay? So you see how you got 9 out of 53? You want to know how many would you get out of a new total, which is 50.
Oh,
And I'm just going to cross multiply. 53 times x is 53x, right? Here's my little butterfly. And 9 times 50 is 450. Can you do 450 divided by 53 for me? You should get 9 again because it's so close.
8.49.
8.49. Oh, it's down to 8. Wild, right? Because this is less than 5. So 9 out of 53, you would probably get how many out of a bag of 50? Only 8. Now, there's another way to do this problem, okay? We're just trying to predict how many you get out of 50. So, what is your percentage? What's 9 divided by 53? What you get for your percentage?
Haven't done it yet.
Oh, sorry for moving that.
16.9.
Do you see I get 16.9%? That's really what? 16.9 divided by 100 is 0.169. If you multiply that by 50, guess what you'll get? You will also get 8.49, which is 8 of those M&Ms. So you got 9 out of 53. We're saying mathematically, if you only picked to 50, you should only get 8 of them. We're predicting how many you would get with different bag sizes. Did that clear it up? Let's try another one. You had a question too, right?
Yeah, so if I got 14.28, it would be 14.
Yeah, you round out.
Okay.
And if it's 0.5 or more, it's another M&M.
Okay.
But 0.2, like you round down, but we're doing whole numbers because we're predicting amounts of M&Ms.
Okay.
Let me do another example, Sam. How about you give me your amount for, give me another color. Give me blue.
11.
So you have 11 out of 53 blue, right?
Yeah.
I want to know how many you're gonna get out of 50. It might be 11, it might be 10, right? So we're just gonna cross multiply. 53x equals 550. What is 550 divided by 53? You should get about 10.
10.37.
So it's still 10. So if you had a bag of 50, you'd most likely get the same amount of M&Ms. This get clear? Okay, so I'm gonna give you guys like 5-10 minutes. Work out your probabilities. I want to see this chart full. Soon as you get stumped. Hi. Oh, okay, already. Sorry. I won't eat any of yours, I promise. How come yours are orange and whites? Okay. What's that?
Or have that,
What do you mean?
because
Oh,
50. All these add up to 10% more.
oh, yes, right. So you're trying to add these together? Let's see.
Yeah, these was,
I'm just curious. Never involved.
That's what that is. Thought I was on.
Oh, okay, cool, I like that. How am I getting an extra 5?
It's 10%, betting 10% for all three of them. But
I think it's because you have this total on the edge.
but I don't include that in there. Double click and say, on the, what these thing. It's just by now, I'm not sure where it's getting the 10% from every time.
Yeah. I would just, so these are your numbers, right? So let's just take your, oh, but this is for each of them moving up, right?
Yeah.
These are your original probabilities?
Mhm.
Just give them on the side. And let's see what happens. So you're doing this move, right? You're using Excel to make your life easy.
Mhm.
So you're just doing, equals 50, times, these, right?
Mhm.
So. Oh, I know.
You gotta do the parentheses,
Oh, really?
order of operation.
Oh, yeah. So let's try that again. Something here.
Oh, it didn't have 3D. I'll work on that.
Oh, so maybe that's what's happening.
I use this.
Oh, you use that?
To
Oh,
my whole algorithm.
so convenient.
It's like that's one.
I totally get it. Okay, let's try one more time. So. Yeah, you did it right.
Sum of all of that is
6, and then because you got 12 originally, that's right. That's,
Times 50, it's 55, and that's 10% every time. I'm not sure why. Different.
is it because you have a decimal here?
Yeah, but I rounded up.
There are just 5 or missing. But you're like, I should get 50 at the end. Yeah. Because you have 50. Unless every single one of these, when you're knocking them out, they're just giving you like an extra bit that attaches to it, but that's only gonna give an extra 2. That's why it's a little weird. I see what you're saying. Because this is 6, this makes sense. Well, this is one more. Yeah, it's because it rounded up all these. Every one of these is round up, so you have 5 extra. See, because this should really be what? It should be 11.5. Yeah, but you got 12, that's gonna give you an extra one at the end. They're all, like, most of these are getting round up. And that's why it's gonna be attached more, and that's why you're getting the 5 extra. That's where you're just getting 5 extra, and this is why you're getting 50 extra, which is.
This is 20 bucks. Like I said, it's 10%.
Yeah.
Absolutely.
Yeah, it's weird. Well, let's actually go backwards, right? So let's do the, 150 divided by 500. Why don't we just go backwards? The one random one to see if there's a mistake. 30%, it's backward. You can find it, I'd be interested, but this is good to me. Because these aren't the, I think it's just what the estimation on top, but that's still like kind of hurting you a little bit. It should give you that much extra for each time. Whenever there's something like that that's so weird, I would always just plus new sheet and just work it out again. But I doubt it.
I'll fiddle with it.
Yeah, fiddle with it for a little bit before you move on, but I would totally accept that.
I don't know.
Oh, so how many did you have of the brown? 3, so it's 3 out of 40. And then you just multiply that by 50, so space plus Whatever you get, you're gonna multiply that value by 50. Not gonna give you. How many round pieces you get? That would be 3 divided by 40 times 50. Just get equals first, if you want, times 50. Ta-da, so it's 4. So, that's enough. You can do that for all of them. So the next one's your red, so you have 7 out of 40, and you just divide it, then multiply by 50. You're welcome. Anybody else stumped? Besides Arya's computer being weird. Yay. That's looking good. That's looking good. Oh, you're doing by hand? I like it.
Yeah, so the shortcut is plug this in.
And multiply by total.
Yeah, okay.
Yeah, so give them 50, 100, 250. So you just take these numbers, and multiply by 50, 100, 250, 500.
Okay.
Are we good? Yes. Miles, you good?
Well, so which villain probably, that's talking about the first one, right?
Yes.
Okay.
All right, anybody else need my assistance? Doing good? Yay. How you doing? You're fine. Look at that. You good?
I think so.
That looks good. Yeah, keep it up. If you just excited, you just drag it down. You know, you can do it once and then just drag it for the rest. Do once, drag it for the rest. Just keep it in mind.
Oh, yeah.
Figured it out. Nice. Where was the mistake?
Put in a 2 instead of a 1.
Okay, well, that'll do. I knew it was a stupid mistake because all your equations were right.
Yeah.
That's why I was feeling crazy. How are you?
Right.
It should be.
Okay. And then.
Okay, sure. Would you mind just reading yours out for me so I can put all yours in?
Yeah.
Cool. And then we're gonna make bar graphs. Who's excited? And which of your bar graphs have 5 different colors, right? A color for every bar. All right, so you're gonna have to read them off to me. So read your first line. I started with 8. What's your last color? Oh, yeah. Because some of them, oh, I have this because some people were like, I want to use Skittles over the summer. So I changed it to be other. Because there's like some weird tropical colors. All right. So the last one was, what was orange? Cool. Keep it going.
19 and 30.
You're going to have, so it's just 15, right? Okay.
Wait. Yeah,
15. Keep it going.
12, 12.
Yeah, it should be 30 because 15 doubled is 30. So another way you can think about it is once you have Sam, and even other way, you see how this is 50? What's double 50? 100. So you can just double these, but most of them will work. The top one didn't, but like, look, 8, 6, 12, 6, 12, 10, 19, 15, 30. It should be close to double. All right, keep it going.
48 and 77.
And you should be having your equations here, whether you did it that way or the other way. And the last one? All right, cool. So we should all be pretty close to here, right? Yeah? Okay, so now we're going to create a bar graph for your experimental probability. I think this is the biggest mistake that a lot of people had. A lot of people ran into trouble right here because they're like, what numbers do I use? You see how we have like an amount of 50, an amount of 100, amount of 250, amount of 500? Doesn't that sound kind of tough to think about? So I don't want to just tell you the answer. I guess I could, but really think about it. Are all of these pretty much in line with themselves? Aren't all of these the same percentages? Do we need 1, 2, 3, 4 different graphs? Or would we get the same value if we just used our percentages? Because it's the same percentage for each. That's up to you. Could you make your original, right? Your original bars for frequencies and then have what? 2, 3. Could you make 5 sets of bar graphs together? Yes, that would look cool. You can see how they change a little bit as you go through, or you can make one bar graph with the percentages. So you can make whatever you want here. I would just implore you, titles, axis titles, show me color, really make it clear. I would really try to make this as, what do you think would be easiest for people to see? We want to show what? We want to show how many were picked from our original 50, 100, 250, and 500, right? We want to be able to show that. What do you think the best way to show it is? Do you think it's 5 different bar graphs put together? Or is it one bar graph? Like, I know that's just like a question I threw out there, but what do you think would be easier for you to see? What do you think is easiest for you to kind of understand this data? All I care about is for your bar graph to have titles, axis titles, and color. Why do I want color? Because the whole point of this is to show what the different colors do. Does that make sense? So I want everybody to try it. Okay, I'll make one in a minute, but just really try to make yourself a bar graph. And I don't care if you have 5 or if you have 1, just I want to see the data. Sound good? All right, cool. Can I check yours? That looks perfect. I think that looks great. You can move on. That looks awesome. What would I probably change? I'd probably make the width bigger. I really like the data labels, and I might even take out those lines across. Nice, I think that looks better, and I'd probably make them a little wider. I'm just trying to like help you like make it look better. So if you actually just get this, right, we have the axis, and we can go here, axis options. All right, so I guess I do have to click these. So I'm just gonna change the width. I think that's easier to see. I think it's way easier without the lines across. Make sense? Cool. Let me see how yours is coming. Oh, you're putting it all together. Okay. Whatever works for you. Let me help you make a bar graph if you want me to. You're still getting there? Keep it up. How you doing?
I'm doing fine, but I did all of this by hand.
So now you have to write it down.
Yeah,
That's okay.
yeah.
It's not a big deal. Keep it up. You're flying through it. You need my help? Are you good? That's okay. Take your time. Take your time. That looks perfect. That looks perfect. All right. You're gonna change those colors for me, right? Okay, you're gonna let me know? I want it pretty. How are you doing?
I can just get it leave one.
That other part?
Yeah.
Okay, whatever works for you. I'm not rushing anybody. How are you doing?
So for the bar graph, like,
It's your choice.
oh, okay.
So you can use that, the percentages. I just want you to show me how you think it'd be easiest to express the likelihood of getting the colors. You have all this data, right?
Yeah.
What's the best way to express it? Just one percentage, your original, like the 4 different ones you made, like what do you think would make it look the best? It's up to you.
Okay, sounds good.
If you want me to do one for everybody, that's fine, but the whole goal is to kind of see how you can express this data. You getting there?
Yeah, kind of.
Kind of, okay. You let me know if you need me.
Yeah.
Perfect. What do you want? That one, okay, so you're gonna do out of 100, I like it, cool. What made you pick that one? Do you think it's easiest because it's out of 100?
Yeah.
Show people, I like it. Just make sure there's a reasoning for what you're doing. You're good? Somebody did like all yours are pretty much the same, right? Okay,
What happened here?
because you didn't make a histogram. You wrote histogram, but we have to do a what insert? Sorry. It was like blinking all crazy. Oh, and see, that's not what we want. So we just want a. So you have something that's not there. So when you're highlighting it, we don't want the color.
Oh.
So do it again, then you can click this one. But really think about what you want for your access title, your regular title, do something with the color. Okay?
Awesome.
StatCrunch might not be your friend for this one because you can't do like any customization. Just
Okay.
keep it in mind. I'd probably use Excel for this.
Okay.
Can you use StatCrunch? Sure. I'm just saying you can't really, it's just so hard to put titles on it and like
Yeah.
you can't put colors on it, like.
Mm.
But I'm not gonna stifle you. If that's what you use, that's what you're comfortable with, cool.
Great.
This looks weird.
Yeah.
Get rid of that. So the best thing to do is click here with the plus sign and stuff. We wanna get rid of the. Oh, you want one at a time? You wanna show you, or you're gonna play?
It's not, this is all on set data.
Yeah, so you can, I can show you. Got your back. So you have to just click one individually first. Have it. We have them all together. I know it's giving you just one.
It's like that.
There you go.
I mean, did I help that? I might know.
There it is. So you just have to left click it. We want red. You got it.
Oh, okay, thank you.
Yeah, of course, that's why I'm here, right? This one, oh, it's already blue.
I
Okay.
thought I did. I thought I went over that, but I guess.
No, you're fine. That's why I wanted to show you, like, I really want to help you make some good
All right,
charts.
thank you. That's much
Yeah,
easier.
you're feeling good?
Yeah, that's perfect.
Okay, I'd probably stretch it out. I'd probably move this up. I don't think you need that kind of label. You know, I would get rid of the title for your label. What else would I do? Just make sure you don't do the series thing here. And just worry about your like access titles, okay?
Yeah.
And I don't think you need the lines across the board.
Yeah, thank you.
If anybody needs graph help, I am here to help. You have something? Sure. That's looking good. I would not add this. I don't think you need this part. I don't know. You spelled your colors weird. Just so you know. Nice. There we go. Perfect. I would probably put a number of M&Ms and I put a title here, but this looks good. Well, we're changing that. You want it orange, right? There you go. Don't make them what they are. What's this one? That's your yellow. Okay? You feeling good? All right, anybody else need help?
Do they use frequency or the percentages?
It's up to you. It's however you think is the best way to express the data. Okay, I think that was good.
Okay.
So you have what, where are those numbers, what, say original? So you wanna use your original, that's fine.
Okay,
So you can use whatever you want as long as you have like a reason. Does
okay.
that help?
How did you change one color at a time?
I got your back. You just have to click on one,
Oh,
and yeah, just click that and make it your, well, it is already looked like, yeah.
oh.
Any color you want, okay?
I have all the numbers.
You good?
Okay.
Your chart looks great. Oh, you don't know a name? So maybe like color predictions of M&Ms? I don't know, it's up to you. What are you trying to show people, right? That's the whole idea. It's like, this is my expression of the data. I've had to do this so many times when I was like doing data analysis. They always want like, what is the best visual to present the data? So I think your way's good. I would probably just get rid of these lines in the background and I'd make these a little bit, like wider. Why is that? I think I think they're a little too thin. Right? And I don't really like these lines in the background. I think these lines are kind of, I get rid of those guys. Oh, well then don't click that. Yeah, so you just go to, yeah, there you go. Okay. You're fine. It looks great. But that's probably what I would do. Yours looks good. Feel free to move on if you already have your graph and you like it. If you hate your graph, I'll help you with the graph. So here, I'll show you one. You're done. I want a paragraph. Describe your process How horrible was this whole process, right? When you're done. Do you think your results are similar to other students? Well, you can just look to your partners. Like, do your graphs look the same, right? What else is in there? Ooh, then we start experiment 2. I'm excited.
And
Look at your part, like walk around, maybe look at a friend's graph. God bless you. Everybody look at least one person else's graph. Lee, you doing okay?
Can the title just be M&M?
If you want it to be, does that really express what you're trying to show? Prediction? Color predictions? I don't know. It's your graph. Do I give out Fs all the time? How many Fs do I give out? Like, honestly, I just want it to be what, something that makes sense for you. And we might pause in like 3 minutes just to make sure we do the other experiment too, okay? But I'll show you one. I'm just gonna do frequency. I'm gonna write number of M&Ms. Why am I gonna write number? Because some people don't understand frequency. If you want to make sure your graph can, reach the most people, use simple terms, right? I have color and number. Does it get simpler than that? I hope not, right? Like, we got blue, orange, brown, yellow, green, red. I like people going out of 100. That's cool. I like people doing the percent total. It's up to you. I'm going to do the percentage. So I'm going to do 19.2. I'll do 30.7. 15.3. You can use whatever you like. Okay, so if I'm in Excel, I'm gonna highlight these. I'm gonna go to insert. I'm gonna click this one, just a regular 2D graph. I hate the color. I want the colors to match. I want blue to be blue. So I left click it and I just click fill and I can make it any blue I want. Orange, I'm gonna left click it and I'm gonna make it orange. Sorry about my eyesight. I'm not the best at seeing things, so if my colors are weird. Oh no, I got them all. So if you ever mess up, you could just hit undo. This is the green one. And finally the red. All right, I really want to make sure we get to the harder probability stuff. What are things I would add about this? Titles. It needs titles, right? It needs titles. I would put data labels on it. But as long as yours looks something like this, you're good to go. Okay, sound good? Where do I take off points usually? Not a title, no axis title, no axis title. That's bad. No data label. I like knowing what each of these are. So I don't have to be in red and be like, how much is that really? So I don't have to look all the way across, right? All of those things help your, they all help your viewer see what's happening, right? Now the numbers are above it. All right, cool. All right, so whether you're there or not, I'm worried about time. So we're doing experiment 2 and the experimental probability. Is that okay? Can we move on? Because we're moving on. All right, so did anybody eat their M&Ms yet? You can if you want to. You just need 2 brown, 2 green, 2 yellow, and 2 red left. Eat the rest of them. Or put them back in the cup. That's all you need. I would actually just put the 2 in the cup instead of putting the other ones in. Question. So come grab some. That's why we have more. So, place these in your cup, right? We don't have a bag. So I want 2 of each in the cup. The rest of them, what can you do? Eat them. Sound good? So grab more, because you're gonna want more. So we are doing our second one, right? All you have to do is draw one and not put it back in the cup. And then draw another one and put it back in. And then after you've taken out the 2, put those 2 back in the cup. I'll say that again. So what are we doing? We are taking one out of the cup. We are writing what that is. We're putting it down. We're taking another one out of the cup. That means you take 2 out at a time. Then what do? Put them both back in the cup. Then you do the process again. I'll say it a third time. We have a cup with 2, 4, 6, 8, right? There's 8 in your cup. Take out one, look at it, put it next to the cup. Take out another one, look at it, put it next to the cup, and we're just tallying them. Does that make sense? All right. Do I need to say that again? I probably do, right? I will say that a 5th time. So how many are in your cup? 8, right? All you have to do is take one out and look at it. Mark wherever it is for the first row. Let's say your first one was red. I had a red one. Okay. Then while that's outside of the cup, take another one out. And let's say that one was yellow. Your second one was yellow. You're just putting tally marks. Is that okay? I didn't make the chart. No, it's not the best chart, but that's what it is. Yeah, you do it 40 times. That's it.
40 times.
We could change that to like 10, but that's what I didn't make the lap. Back in and then do it again. Okay. And then yeah, and then do it again. I know that's why the chart looks weird because it's first red, but it also says second. So you just put them. Doesn't really matter.
Or-
Yeah.
Is it not saying that you do the first, go to that sale, or you go to that row, and then the second will decide what go, and you only do one tally?
Oh yeah, you're right. It is only one tally at a time. You are correct. Because I haven't done this in a minute. So ready? So let's say your first one was red and your second one was red. That's a tally. So you should have 40 marks at the end. So let's say your first one was brown and your second one was yellow. That's a tally. You just need 40 at the end. All right. I heard a lot of O's. I'll say it again. So let's say your first one was green and your second one was brown. That's a tally. And at the end, you should have 40 marks. Sound good? All right. So see how quickly you could do it because everybody messed up the theoretical probabilities and we're not going to mess that up. So we need at least 5 minutes at the end where I can run through these for you. So 40 times, go for it. And make sure you're eating them. Make sure you're eating enough of them.
So we draw another to put the goal back.
Sound good?
And then
Yeah.
rush one?
Yeah.
Yeah.
Your first one was red, grab another one. Your second one was yellow, so grab a red, yellow. Sure. Oh, wait, so you pulled a red and then another red?
I did 2 reds and then that was.
Alright, so we're gonna. So after you pulled out 2, so
I say I would like to take out yellow and the first one, so on the chart. Your second one. All right, we'll have
Good
the
yellow, grab
first
this one.
Both 2 go
Yeah,
first.
so yellow, brown. You got a yellow. and
The
then-
first one was brown. The second one was red. So
They
the
can
red
be,
is the
so they're
top.
different. That makes sense?
Yeah, okay, good, yep.
Show me. Red, no, one at a time.
Sorry.
And then one at a time.
I'm cheating.
Red and one more. No, you don't
Oh.
mark it. Yellow, so we need the red first and yellow second. Feel good?
Yeah.
Okay,
And then put it back in.
yes, and then do it again. All right, are you okay? All right, you know what you're doing. Good. So walk it away. Make sure you're eating enough. I'm looking at the clock. Yeah, you're good. You gotta get all the ground. Process. Red and then red, double red. You okay? Okay, sure?
Yeah.
Okay. You're in the M&M's slide. Keep it up. Ooh, double red green. Interesting. Now yellow. Kenyon, are you good? Okay, we're getting there. Can you make it to 40? Who knows? As long as there's 40 tick marks, if you got bored. You should have 40 at the end. So this is why in math we have things called simulations. And while you're doing that, I can show you a simulation of this, where I can literally type in the probabilities and it will automatically do this for you. There's a bunch on Rossman Chance. Good, God bless you. But there's a lot of programs that do this type of stuff for you, so you can see a simulation. Now, I know they have a cool one with Reese's. So just so you know, this is an applet that can do simulations, and I'm gonna look at the one that looks closest to what we're doing right now. Reese's Pieces, cool. See, look, here are all the Reese's Pieces. The number of orange, let's say the probability was like, I don't know, 25% orange. Let's grab 8 samples. And let's say we're doing 30 candies each. I can literally do draw samples. See, it's grabbing them and it's putting them on the bottom. So there's a bunch of applets that does this. So this is going to do this 8 times. So you could always use simulations for this, but the lab wants you to have the experience of doing a 40 trial. But I'm making an 8 trial and I can show previous results, boom, and sliders. See, look, it just did another one. Ta-da. So there's all these applets that do this stuff for you, just so you know. So you can like have it set and draw samples as many times as you want. I'm gonna eat some myself. Almost there. More now. We can do it, and then we'll do the final card. Cool. Needed like somebody with the You do it? Cool. Do you have one? Does anybody have one that's definitely more?
Yeah.
Yeah? Isn't that weird? Shouldn't they all be equal?
Okay.
This is why gambling is bad. Oh, wow, yeah. These your numbers. Well, that's pretty even. That is pretty even. Yours even? Not so much. You've never gotten a brown?
No.
That's kind of crazy. That was really good. You have got red. Interesting. You never got a brown middle. That's crazy. Did you eat the browns? They're in there? You got at least one of each? Cool. Okay, you can stop. As long as you got close to 40, right? All right, for the sake of time, I wanted at least 10 minutes to do the rest. Can you save these M&Ms and continue? Sure. If you want to stop where you're at, you can make up a couple more. I promise I won't take off points. You should just make sure you have 40 in your chart. Now, I really wanted to go over these last problems because these are the ones that look like your test problems. And after today, we're probably not going to talk about probability again. So I really want to make sure you know what probability is. Now, what is the formula for probability? What you want over the total. That's all it means. So you see how this says theoretical. Theoretical. What does that mean? We did an experiment up here, right? Theoretically, they should all be equal. Does that make sense? If we have 2 of each, shouldn't they all have the same amount? Theoretically, this makes sense. So here we go. I'm going to try the first one nice and slow. Good thing Alejandro's here. Can you read the first one for us? All right, so out of 8, we want to pull a brown. We want brown. How many brown are in our cup? How many in total do we have? What's 2 over 8? That's 1/4. Always write all 3. 1/4, 0.25, or 25%. Was that okay? Or did I do that too fast? All right. REA, it's up to you. Read number 2. We are not replacing this, right? So the total is going to change. Once we pull out a brown, so this is what happens. We have 2 out of 8. What's the probability that the second one will be brown? How many browns do we have left? How many are left in the cup? So it's top times top. What's 2 times 1? And what's 8 times 7? 56. We can simplify this to be 1 over 28. Can anybody do the division for me? 1 over 28. Looking at you, Miles. Unless you're too busy eating.
3.5%. Or 3.6.
Give me the decimal first.
0.0357.
Perfect. So I want the fraction, I want the decimal, and we're going to go with 3.6%. Sound good? Any questions about that? Maybe that's why we didn't get brown. What are the chances of really happening? I don't know. All right. I need somebody to read the next one. SB, I appreciate you volunteering. Oh, she's eating. Leah, thank you for reading the next one.
Look at the multiplication.
Oh, no, it's like once you first pull out.
Oh, once you pull out, the second one will be a red.
So we're still starting with 2 out of 8, but what's the second one going to be? Think about this. Tell me the fraction. Great job. Can you explain how you did that, SB? Perfect. Exactly. Oh my God, you guys learned probability. And we're multiplying because it's harder. If it was or, if it said the word or, we would add them together, right? But because it's and, it's going to be 4 out of 56, which is 2 out of 28. which is 1 out of 14. Okay, I need the decimal.
0.0714.
0.0714. I'm gonna say 7.1%. We feel good? Any questions? I love the questions. We're okay? All right, another, I guess, human. Ashley, would you mind reading the next one? We're at look. So what is the probability that both the first and second M&Ms are brown? What does that mean? Let's think about this. That the first and second M&Ms are brown.
The first one fold is brown and the second one fold is brown. Would it be the same as the second question?
That sounds perfect to me. I'm not even gonna look at the formula. I'm going with 3.6%. The probability of the first and the second being red. What is the probability? So did we mess this up? Once you first pull a brown, what is the probability that the second one will be a red? So I think maybe we messed up the first two, right? Because it says the word once. Is this just asking us once you first, what is the probability that the second one will be another brown? Is this like an independent event? Could this just be a 1 out of? Could this just be 1 out of 7? I just hate the way that they're worded. If you put 1 out of 7 here, I will also accept it. If you leave it like this, I'll take it because it's worded differently. And the second one will be red, will be what? 2 out of 7. I'm pretty sure that's what they want. They just worded these so bad.
They just want the fraction.
They just want the frac. They don't want it to be the combination event like these two. Does that make sense? I don't like it. Because it has n, which means multiply, and it has n, which means multiply. So this one, they just want one. They just want what happens in the cup. So I'm crossing this out. Or I'll probably erase it so it looks nice and neat. So number 2 should be 1 out of 7, and number 3 should be 2 out of 7. They worded these so poorly, but that's okay. I didn't write it. All right. The first one's totally right. Well, we only pulled 1 out, so this one's 1 out of 7, and this one's 2 out of 7. Sound good? I'm trying to think of anything else. Oh, we should put the decimal in the percentage, right? So 1 divided by 7. And then we need 2 divided by 7. We got 1 over 7, which is 0.14. And 2 out of 7 is 0.28. Well, which makes total sense. We got 0.14, 14%. And 0.28, which is 28%. We all make mistakes. Even I do. It was poorly worded, but that's okay. Really think about the wording. I don't want that to be what messes you up when you take the test, right? Because the wording is really important. So they're trying to say that these are dependent events. So once this happened, stop. What is the probability that the second one will be another brown? It's like, well, we took a brown out. There's 1 brown left, 1 out of 7. Once this happens, we still have 2 reds, but we took 1 out, so that's why this one's 2 out of 7. It's just poorly worded, but I'm okay with it. Now, what does the last one want you to do? What does it say? Write a what? Paragraph. What does that mean? I need 4 sentences. Can you give me 4 sentences? I hope so. What patterns did you find? Describe patterns that exist. Did your theoretical probabilities match your experimental probabilities for the last 2? Did your brown and brown red match what you got? Yes. It should be, yeah, it's 1 out of, it has to be. So we have 2 out of 8 times 1 out of 7. And then we have 2 out of 8 times 2 out of 7. So this should be 2/56, and this should be 4/56, which will be 7.1%. All right. I somehow made sure we finished a whole lab in the really short allotted time. We did every piece of it. Eat the rest of your chocolate. Next class, I don't know what we'll do, but we're definitely just doing homework for moving forward in here because I didn't get enough homework over the weekend. Please let me know how I can make your class better. I want to see more work from you. All right, let me know what's going to make your life easier. Please, if you need me to make more videos or do something else, tell me. I want everybody to get an A in here. Okay, that's the goal. I also moved back all of the work that's been due so far. So if there's anything you're missing, feel free to turn it in. Okay? Enjoy your evening. I know it's late. Eat your chocolate. Take care. Yeah.
Are you gonna put that on?
As long as you shoot me an email that says you redid it,
Okay.
I'll look at it and I'll put the higher one.
Thank you.
Yes, because it doesn't automatically do it. I have to go in and change it.
Okay.
Sound good? You good? Oh, it was fun. Cool. I'm glad. Eat your chocolate. Are you good?
Yeah.
Awesome.
Thank you so much.
Of course.
Bye, Kelly.
Can you show me how do we change the color on
What is this? What happened? Why is this one full?
Oh,
yeah, it's full.
Yeah.
We're gonna get rid of that.
Okay.
How about you sit here and I'll pull over a chair and I'll help. I know you're not used to using this, so. Here we go. So I'm gonna just make a new one. Is that okay?
Yeah.
I'm just gonna highlight these. I'm gonna go to insert. I'm just gonna click the first one. That's it.
Oh, okay.
Cool.
Mhm.
And we can add titles by just clicking here, titles, boom. You just write in whatever you want. I would probably make these capital, just so you know. And then if I left click one of these, I can make whatever color I want. The first one was
Oh,
blue,
okay.
now it's blue. This one was yellow. Ta-da, and you can make whatever you want. Now, if you click this, you can add the labels.
Mhm.
I know exactly what they are.
Okay.
And you see how it says, grid lines.
Mhm.
Now, right,
Yeah.
now if we click. There's so much, like, make better, that's why Excel is good. I click here. Thank you, see, there's that. Aria, you good? Yeah. Awesome. So I'm just gonna go to axes. And you see how it says primary, horizontal, more options, I'm gonna put more options. Now I can change the actions options. I just want to make them bigger. All right, so I just had to click it and change the width. Now I've got see it
Okay.
better, and you can do like all this changes, right?
Mhm.
You can change the fonts, you can make it bigger, you can put like that. This is the reason why Excel helps,
Yeah.
is because you, in StatCrunch, it just, oops, I did them all, sorry about that. So if that ever happens, you can just click undo. The StatCrunch, you just get the stock one, and I feel
Mhm.
like you're trying to express your data and really do a lot.
Yeah.
So for this one, if you want to use StatCrunch for the rest of the class, that's totally fine, but I just want you to see that you can make a good looking graph.
Yeah.
I don't know if you're
So
ever
you
gonna
did
use
it
it
with-
again.
Insert, and then it wasn't the histogram.
Oh, yeah, from the beginning, oh, yeah,
Yeah.
sure, so just when you ever want to use it, so it's not histogram, it automatically like puts them in categories for you.
Uh-huh.
So if you just go to insert. I just went to the first one, which is the column graph,
Oh, okay.
that was my base.
Okay.
And, or you can go click here, and you go to recommended charts, and it's the first one.
Okay.
You literally click the first one, and it automatically pops up.
All right.
So that's just literally the first recommended chart is
Yeah.
a bar graph.
Okay.
To make it into a histogram, all you have to do, if you want to use this, and you like this better, is just That's correct.
Yeah. Okay, all right, thank you.
Yeah,
Have to play with Excel more.
you don't have to. If you hate it, don't use it. It's
Well,
just
it's over here.
Excel is free.
Yeah.
StatCrunch is a paid program, you know, like. Why not use the free programs that I think are better, but it doesn't matter what I think, you know, it's whatever's useful for you, okay?
All right, thank you.
Take care.